Hi everyone, so in today's video we are going to speak about statics. We are going to study about moment mainly, okay? So moment, as you see here, at point O is equal to, or for force F1 is equal to the distance R OA. Why ROA? Because you can see here we are doing moment of point O, and then at point O for force F1 is equal to distance ROA is times F1. So we can see here that distance ROA is actually the distance between F1 and point O, where we are actually doing our moment. So uh, that's how you represent moment, because moment is actually a rotational force, and so there will be, instead of saying right is positive or left is negative or upward is positive, you can say here the anti-clockwise direction is positive, or the clockwise direction of is positive, and so on, because it's a rotational force, and this rotational force is actually distance times the force. So if you want to represent now this in a vector form, because in question one they asked us to express the components of the forces F1 and F2 in a vector form, okay, for the moment. So how do we do this? We have already written this equation, okay, so keep in mind this equation, and then if you want to move on for the next step, for sure you can write moment at point O, okay, for the force F1 is equal to, you open a matrix or a bracket, and in this bracket you have I, J, and then K. Okay, so what is supposed to be in this matrix? You are going to have R and F. Okay, so you will have R over here and F over here. So this is going to be R in the X direction, this is going to be R in the Y direction, and this is going to be R in the Z direction, and then this F in the X direction, this F in the Y direction, and this F in the Z direction. But sometimes we don't have an impact of these forces in that direction, so we will write zero. Okay, so we will see, let's see how do we do this. Okay, so distance in the X direction, we can see that this distance is actually OA, it's in the X direction, so that's what we can write over here, L over 2. Do we have any distance in the Y direction between O and A? No, we actually don't have, so we are going to write 0. And in the Z direction, which is actually out of the page, as you see in this figure, and so it is also 0. We don't have any distance in the Z direction. Okay, right now this is for the force F1. So our force F1 is actually in the X and Y plane. So there is an angle with the Y axis. So going back to mathematics, this is going to be F1 cosine 60. Okay, so if you don't know how to do this, let me know in the comments. I will do a special lecture about this, okay? And this is going to be F1 sine 60. So what is here? This is the x-axis, right? The horizontal I-axis. So this is going to be F1 sine 60. This is going to be F1 cosine 60, and this is going to be 0 because we don't have a force in that direction in the z-axis. So right now, if you just multiply these components inside the matrix, you are going to cover this and this, and you will multiply this times this minus this times this, which will actually give you 0 in the first row, and then you will close this and close this, and you will multiply this times this minus this times this, which will actually also give you 0, and then lastly you will close this and this, and you will multiply this times this, which will give you L over 2 times F1 cosine 60. So L over 2 F1 cosine 60, and I'm going to close the bracket minus 0 actually times this, so it will give you just 0, so that's why I closed the bracket already. Okay, so this is actually your first answer for the question. Now you can also do moment at point O for F2. I'm going to keep this for you, and if you have any question, let me know. So this also will be your I, J, and K, and then you will have the moment or the sum of the moment, right? So you will also do this. You will notice here that f2, there will be negative in the negative direction for sure, because your f2 might rotate the system in the anti-clockwise or in the clockwise direction. So you can do this yourself and let me know if you need any help. I'm going to post or send you the answer even. Just write in my email. You can let me know in the comments if you need it. Anyway, for sure you will have also moment at point O for the total moment, which is actually f1 plus f2. And so you can, like, you got this answer and you will get another answer over here. So you can sum these two results together and you will get the moment, the total moment of f1 and 2. And you don't forget that actually it will be in the uz direction, because it will be in the, I mean, as you see here, this is the z direction, right? This is the k, because this is your j and this is your I. So your moment is actually a rotational moment. It's in the z direction. That is what we said here. Moment is actually the rotational force. So that's the end of the first lecture. We can also solve this by scalar form, not in the vector form. So you can do the sum of moments around the point O, and this scalar form is just easier than this, and it's not time taking as this. So you can do the sum of forces in the y direction is equal to 0, and you assume that upward is positive. And you can also do this, the sum of moment at point O in the, let's say, anti-clockwise direction is equal to 0. And then you start doing this, okay, assuming that anti-clockwise is positive. Then you can see here these forces actually make the system rotate in which direction. Okay, hope you understood this lesson, and if you have any question, please let me know. If you also want me to send you the files for this specific questions, I can